Okay, so in this chapter 10 over here, we have another subtopic, which is 10.3. That is what we are going to learn today. It is about the relationship between perimeter and area. Okay, so it is regarding to what we have learned in the previous lesson. You see the perimeter, we learned it in 10.1. And then the second subtopic, we learned all the area. So now we are going to determine what is the relationship between perimeter and area. So this is the first thing that we are going to learn later on and solve problem as usual. Okay, let us look into how to find the relationship of the perimeter and area. Okay, this is the first part here. Hold on. Okay, first part, what is the relationship between perimeter and area? Kasim has a plot of empty land. You imagine he has a plot of empty land. He wants to fence up a region of the land to plant some vegetables. He has a 20-meter length of fence, okay, meaning that he has a satu gulong of fence like that. He has 20 meter, okay, and then how should he construct the fencing such that he have a region with the largest area? So we need to figure out how to get the largest area later on if you want to fence his land. For example, if we have this land like this, the shape of the land like this, the shape of the land like this, which one will give you the largest area to fence it out? Okay, now we are going to look at the next question here. This question is about state your conjecture for each of the following. State your conjecture. Conjecture means assumption. Andaian. Okay, so you have to make assumption over here for the following. The first one here, how does the area of a rectangle change when its perimeter is fixed? Okay, you got to imagine what will happen to the area when the perimeter is fixed. And the other question over here is the other way around. How does the perimeter of rectangle change when its area is fixed? So it's the other way around of the first question over here. This one is about area. This one is about perimeter. And then this one, what will happen if the perimeter change? This one, what will happen if the area is fixed? Sorry, not change, is fixed. You're given a fixed value. So we are going to look into the first part here, whereby the perimeter is fixed. We will see what will happen and what is the conjecture that we can get. Okay. So this is the one. I've already, list down everything for you. For example, we are going to go through this. This one is the perimeter is fixed. The perimeter is 36. Okay, you can see here from the length and width. The length is 17. The width is 1. So the rectangle looks something like this. The length is 17. The width is 1. So you can imagine, of course, both the width is 1 and then both the length is 17. And then when you add on, 17 plus 17 is 34. Okay, plus 1 plus 1 is 2. So altogether, the perimeter is 36. So we have a fixed perimeter over here. Same thing, after I've checked the first one, you can see if I check the second one, the length is 14. Okay, it is shorter. And then the width is 4. So this is 14. This is 4. This is 4. This is 14. 14 plus 14 is 28. 4 plus 4 is 8. So we will also have the same perimeter, which is 36. Okay. Next one, if I look at this one, 10. So with the length of 10 and the width of 8. This is 10, this is 8. So you can see 10 plus 10, 20. 8 plus 8, 16. Also makes up 36. Okay, now for the first one, we refer to the first rectangle over here. So the first length and width is given already. The area is 17. Why? Because 17 times 1 is 17 here. This is the area. Okay. And then for the second diagram over here, you're given the length and width. So you can see 14 times 4. 14 times 4, we will get a 56. Okay. Already stated over here, or else you can get your calculator and then you type 14 and then you multiply by 4 if you are not good in multiplication. So we will get a 56. Okay, so it is correct. It is 56 over here. So this part, 56. And then when you look at the next one here, the third one here, I only show you 3. Actually, there can be a lot. I show you 3 to see the changes. So this one will be 10 times 8. The area will be 80. So you can see from the first one, the first area, which is 17. The second area that we get is 56. And then the third one is 80. Okay, how do we make connection? To make the connection, when the perimeter is fixed, we are going to look at the difference between the length and width. Difference between the length and width means you minus to get the difference. 17 minus 1, we get 16. 14 minus 4, we get a 10. And then 10 minus 8, we get a 2. So you can see all the details is given from the line here. All the line here. Okay. Now we can make conjectures already. Our assumption, that is, you look carefully. The difference between the length and width over here is decreasing. You know decreasing? Decreasing means getting smaller. When the difference of the length and width is getting smaller, you see what happened to the area, the number over here? It is increasing, isn't it? This one?
Yes.
This one is increasing. It's getting larger. It's not decreasing. This one is increasing. So it is the opposite way. Meaning, when you want to find an area for the perimeter where it's fixed, okay, when it comes to the difference that is decreasing, the area will increase. Okay, it is the opposite. So when we look down over here, I have some more figure. When the difference is increasing, the area will happen. What will happen to the area?
Decreasing.
Decrease. It is the other way around. So you just remember, when the difference increase, the area decrease. When the difference decrease, the area increase. And one more thing you can notice from here, I wrap this off. When will the area becomes the biggest? Can you see? The third column over here. The third column is the area. Which number is the biggest?
81.
Very good. You got it. 81 is the biggest. Okay? Then, if 81 is the biggest, you look at the length and the width. What happened to the length and the width?
The same.
They are the same, meaning that they are what? What kinds of shape is that?
Square.
Very good. So, a square will have the biggest area. Okay, so we can make the conjectures already. This one is taken from your book. This is the one. Let me show it to you. I think I show up here. Okay, so when the perimeter is the same, the area will decrease if the difference between the length and the width increase. Okay, this is the one. And then the area will be the largest when the rectangle is a square. That is what you found out just now. The area will be the largest when the rectangle is a square. Remember this, a square. Okay, now we look at the next one. So for the same perimeter, we have done it. This one, when the perimeter is fixed. Now we are going to look at the second one, whereby what will happen when the area is fixed. This one. So I move it. This is the one. So the area is fixed. Area is 49 right now. It is fixed. Okay. So you look at the length and the width. The length is 14. The width is 3.5. Let us check it together. So if it is 14, it will look something like this. This is 3.5. Okay, you can do the calculation. Let us see. 14 times 3.5, how much you get? 14 times 3.5, we will, it's not 4. I retype again. 14 times 3.5, we will get 49. So the area is 49. Okay, I'll show a few to you. 14, I'll take a few. Maybe a 10 and a 7. 7. Okay, 7. So you see, when I do the calculation, 10 times 4.9, of course it is 49. We get that area. And then 7 times 7, we also get 49. So that is a fixed area. Fixed area. Okay, now we will go through one by one. I'm going to show you the rectangle one by one. This one, the length is 10, so it will be slightly shorter than the first one. And then the width is slightly longer. So this is 10, this is 4.9. So we will get the area of 49. All of the area is fixed. And for the third one is 7 and 7. Okay, it is a square. 7, 7, we get 49. Now, we need to look at the difference between the length and width. Means you have to look at the difference between this part here. 14 minus 3.5, we will have 10.5. That is how we get the value over here. Okay, and the next one, 10 minus 4.9, we will have 5.1, this part. And then 7 minus 7 is a 0 over here. Okay, so now what we need to see is what will happen when the difference between the length and the width is decreasing. What will happen to the perimeter when the area is fixed?
Increase.
Very good. So when the difference is decreasing, it's getting smaller. You see the perimeter over here is also getting smaller. So they are decreasing. So I write down on the right here, when the difference is decreasing, the perimeter also decrease. Okay, when we continue down here after the 0, you see when the difference is increasing, already, what will happen to the perimeter? The difference increase.
The perimeter increase.
Yes, so it follows exactly the same, right? So what you need to do is you need to memorize for fixed area, the difference and the perimeter will go together. Means when the difference is decreasing, perimeter also decrease. So we can make the conjectures already. This is the one. Okay. For the same area, meaning the area is fixed, like what we have just now, 49, 49. The perimeter will increase if the difference between the length and the width increase. So this one, I've taken it from your book. I think it's on page 240. You need to change. This one is not correct. It needs to be changed into what? You see, perimeter increase. The difference will increase. So you need to change this to increase. You can refer back to your book if you have your book over here. That is on page 240. That is not correct. Okay? So next, this one you understand or not?
Yes.
Okay, we continue. Now we need to see how to solve problem. Okay, this part is the last part of your chapter here. Look at example 4. Given the area of the square garden is 500 meters squared, find the perimeter of the garden. So you got to imagine, okay, the area of a square garden. What you need to do, what I always do is I'm going to draw the figure so that I understand better. It is a square, so all the sides are the same. And then you are given the area, which is 500 square meter. So 500 square meter, you can jot down. They ask you to find perimeter. Perimeter meaning that you have to find the length over here. And then the length are all the same because it is a square, right? Okay, so what we need to do is you are going to write down to how to find this side. What do you call this again?
Perimeter.
We are finding the perimeter, correct? Perimeter is the boundary for the square over here. But what do you call it? This part of the square. It is called the length of side. Okay, the length of side. I need to write. So, the length of side. To find that, you have learned this in the earlier chapter. I think in chapter 2, the square root, the cube root. So, the length of side, you can get it by square root the area, 500 meters squared. So when you press the square root, you can see from the calculator over here, you press, this is the square root. Hopefully you still remember the button. and then 500. We are going to get 10 third 5 over here. So what do? Is you need to change to SD. It's 22.36. We are going to take 2 decimals only. So the answer is 22.36 meter. Okay? So we have found out here the length of side is 22.36. Can we get the perimeter now?
Yes.
Yes, right. So the perimeter will be 4 times the length because everything is the same over here. Everything is the same. So 4 times 22.36. Then the answer will be, so we multiply by 4. Multiply by 4. The answer is equal to 89.44. And then write down the unit. Don't forget to write down the unit. What's the unit?
Meter.
Meter, correct. Okay. So do you have any question for this?
No.
Understand or not?
No.
Don't understand?
Understand.
Okay, understand, right. I give you another question, a simple question right now. I give you a square with the area of 100 centimeter square. Can you tell me how much is the perimeter for this square? See, anyone can get it or not?
10.
10 is the length of side. I want the perimeter.
40.
Very good. You found it because you square root the 100 and you found the length of side is 10, right? So 10 plus 10 plus 10 plus 10, the perimeter is equal to 40 centimeter. Okay, so you understand, huh? Now we move to the last example. That is example 5. Okay, this part here. The diagram shows a triangle PQS inscribed in a rectangle PQRT. So PQS. This is a triangle. Inscribed means it is inside. Okay, inside the rectangle PQRT. Okay, so the perimeter of the rectangle is 42 centimeter. The perimeter for the rectangle is 42. And the length of the rectangle is twice its width. So straight away, I will jot down like this. If the length of the rectangle is twice its width, for example, if the width is x, the length will be 2x because they say it is the twice of its width, meaning on top also 2x. So this is the width, x. Okay, now we need to find the area of the rectangle PQS. To find the area of the rectangle, I hope you still remember the formula. What is the formula to find the area of rectangle? Area of triangle. Do you still remember?
Base times 1/2.
1/2.
AB.
Very good. AB. Okay, that is the base for A and B is the height. So, if you look at this triangle over here, the base is PQ. The height, where is the height?
X. PT.
PT. Yes, very good. This is the height. Okay, and this one is the same as PT. Hopefully you still remember, this is the base, this is the height for the triangle. Okay, so the first thing that we need to do is we need to find the value of the x over here or the width. So if I use the perimeter, because you are given the perimeter, you see here, the perimeter is 42. So I'm going to add up the perimeter over here. Okay, 2x plus x plus 2x plus x. How many x altogether? How many x?
6.
6 actually, right? 2 plus 1x, 3x. 3x plus 2x, 5x. Plus 1x, 6x. So I'm going to write down perimeter is equal to 42. Okay, 2x plus x plus 2x plus x is equal to 42. So we know 6x is equal to 42. How much is the value of x? X is 42 over 6, isn't it? So
yes.
How much is it?
7.
Very good. So we have the width already. The width is equal to 7 centimeter. Now, we already have the width. Do we know how much is the length here? Do we know the length? Yes, right?
Yeah.
Because the x represents 7, so 2 times 7 is equal to
14.
14, correct. You can write it down here, 14. So now we can get the area of triangle already. Area of triangle is equal to 1 over 2,
1 over 2
times the base is 14.
14.
How much is the height?
7.
7. Very good. So then you can cancel already. Simplified it. 2 times 1, 2. 2 times 7, 14. Therefore, the answer is 7 times 7. 7 equal to 49 centimeter squared because it is area. Okay, do you have any question? No. So you understand very well. Okay, or else for this kind of solving problem, this is what I showed to you. You also can use the one in your textbook. You see the solution from the textbook is like this. Okay, let me show it bigger to you. This is the one. You are going to make assumption for both. So let the length of the rectangle equal to y centimeter. Okay, so they are making assumption for the length of the rectangle equal to y. And then the width of the rectangle equal to x. And your given perimeter is 42. So 2x plus 2y equal to 42. This is x, this is y. That's why they have 2x over here and then 2y over here. And then the perimeter is 42. So they get the subject of the y first, like you solving the linear equation, if you still remember. Y is equal to 2x. Why? Because they said earlier, the length is twice the width. So y is 2x. You see, the length is twice the width. After that, we already have the subject here. We substitute the 2 into 1. Okay, so substitute 2x into the y over here. So we will have 2x plus 2 times 2x. Like this, equal to 42. After that, you solve everything. You get the value of the width, which is 7. The y is 2 times the width. We get 14. And you get the area of the rectangle. Okay, so which one is easier? Which one is easier, class? No answer. It's up to you which one you want to use. Either you are going to solve it this way or you are going to solve it follow the textbook method. So sometimes it depends on the question. Sometimes maybe the question will be easy to solve it like this, or you can make assumption like this. Okay? Do you have any question?
No.